Hi, welcome to Black Belt session on dynamic authorization and policy control for containers. Our speakers today are Torin Sandall and Justin Cormack. Torin works for Stira. He's the co-founder of Open Policy Agent, also known as OPA, an open source project which is written in Go. OPA is actually used by big names like Netflix and Capital One. Torin's been having a rough week so far. His flight from San Francisco had some very scary engine problems. An ATM machine in Barcelona actually ate up his card. He actually has a few demos for you guys, so I really wish him very good luck. Justin's a security guru at Docker. He is a maintainer of several open source projects, most notably Moby, Notary, and LinuxKit. He contributes to all sorts of open source projects. In fact, his first open source contribution was to the Linux kernel back in 2000. He definitely plans to learn Rust this holiday season. He's participated in several DockerCons before, and his favorite bit about DockerCon is the staff walkthrough when it all kicks off. Good luck, guys.
Right, well, we've come with a very, very long title. I think it's too long. I think we should probably remove most of the words from this. It's kind of confusing, but hopefully the talk will be shorter and easier to understand than the title. We've already been introed. Why are we talking about policy? What's this policy stuff? Well, there's a lot of policy stuff, turns out. I just picked a few Legos of things that we've been involved in recently. Probably everyone, as we're in Europe, or even if you're not in Europe, knows what GDPR is. Click on a thing and say, no, that's not. It's more than just a click. PCI DSS compliance is a process that lots of people go through. And then there's lots of specialist ones for different areas. And there's more and more policy. And policies look a bit like this. They're long documents full of rules which you must comply with in different ways and with different priorities. This is from NIST 853, one of my favorite ones. It's actually really readable, but there's a lot of pages of this stuff. So policy is something that really, is more and more something that we have to deal with as developers. And there's problems with policy. It's not the easiest thing. Apart from the very long list of policies there are, we have to deal with the fact that we're dealing with lots of different complicated distributed systems written in different languages with different protocols. And these systems are changing really fast. They're dynamic systems. Containers are spinning up and spinning down. We're deploying new applications. And the whole idea, is to be able to deploy these applications really quickly. But with all these applications, you've got to carry on enforcing all those 3,497 policies that you signed up to do. So how are you going to do this? How are you going to do it correctly, in a performant way, and in a way that doesn't mean spending all your time doing this? Well, when we've got big, complicated, fast-moving, fast-changing things, computers actually are really helpful. And so we're going to talk about how computers can help you solve these particular policy issues and make your life less painful than you might think it's going to be. And so we're going to talk about this with a real life example, which we're going to demo in the demos in a minute. We've got a little pet company, which gives you a lovely pet camera so you can see how naughty your dog has been while you're at DockerCon and your dog's back at home. That's not yours, is it?
No.
No, you've got a cat.
I've
Your
got a
cat's
cat. Yeah, I'm a cat
probably been. So it's always on, always connected, and there's always security and policy issues to think about. So this is the architecture of this application. We're going to focus on two people involved in this. One is Alice, the customer, who likes to watch her cat while she's away, and she likes to log in on the portal and look through and see the video streaming and pay for her service and all these things. And Janet in tech support. What's Janet in tech support got to do with this? Well, Janet in tech support can actually potentially look at every single one of these pieces at all times. And this is a bit of a problem because there's lots of personal data. And and information about whether your home is locked and whether your dog has been naughty. And this is not something that you want anyone looking at all the time for no reason. So we want this company to be a responsible company with a responsible policy. And so this is the kind of example policy we're thinking about. So tech support specialists accessing customer data must be assigned to an open ticket for the customer they're assisting. So this is a policy that makes sense in this environment. It gives you reassurance that not everyone is watching your cat and seeing how cute it really is at all times. And it limits access to a kind of reasonable subset. This is the one we're going to kind of demo and talk about. So the implementation of this, we have authorization for all these different services. And the kind of natural way you think you might do this is obviously it's code. So you sit down in your editor and you start writing a code. And so for the user login, you check if they're authorized. If they're not, it's a 400 error, and then you let them get into their account. And then you have to write a more complicated piece of code for the support person, because this isn't so straightforward. It's not, am I logged into my account? It's, I have to look through all the open support tickets and check if this person is assigned to the account that I'm trying to log into. So this is kind of the obvious way of doing it. You sit down and you write code, and every application you have is full of this code. But this code becomes, this code, there's a lot of this code. You have to write it all over the place. When the policy changes, there's a lot of commits to change. If it requires more context around making the decision, then you have to plumb in more database access. With this time, we had to access the ticket database to access the tickets potentially if it wasn't actually in a data structure already. The customer doesn't have any control over this policy. We have to write tests for this policy, which is complicated. We might have 100 services that are all need to implement this same policy, and they might be written in 6 different programming languages. So this doesn't actually scale terribly well. So we're going to talk about an alternative way of doing this that actually solves a lot of those questions.
Okay. All right. So can everybody hear me? Yep, okay, mic's on. Okay, so thank you, Justin. So I'm going to talk about the Open Policy Agent, and I'm going to start off fairly high level, but we're quickly going to dive into how OPA works, and then show some example policies and how you can interact with those policies. So the Open Policy Agent, or OPA as we like to call it, is an open source general purpose policy engine. So what that means is that you can basically take OPA and you can apply it to pretty much any service in any system at any layer of the stack to help enforce policies. So the goal of OPA is to provide a tool or a library or a component that allows you to unify policy enforcement across a wide range of technology, with the end goal, obviously, of answering the questions that Justin just brought up a minute ago. So we started the project back in early 2016 at the company I work for in San Francisco called Stira. And over the last year or so, we've seen a lot of growth in terms of the number of end users of the project, people that are actually using OPA to enforce policies in their systems. So companies like Netflix are taking OPA and embedding it into their internal platforms to enforce a wide range of authorization policies over internal resources like HTTP APIs, gRPC APIs, message brokers, and more. Companies like Chef are embedding OPA in their products to provide their end users with policy-based control over the products themselves. Companies like Medallia are using OPA to codify and enforce risk management policies over their infrastructure. And there are dozens of companies using OPA today in their Kubernetes clusters to enforce admission control policies, right? Enforce invariance over like the workloads that are being deployed on top of those systems. So this is where we're at today. We've got dozens of companies using OPA for many different use cases across a wide range of technology and all kinds of different industry verticals. And so the project is part of the Cloud Native Compute Foundation. We joined earlier this year in April as a sandbox tier project. We've had about 36 different people contribute code to the project. We've got 1,500 stars on GitHub, which is an important metric for open source projects these days. We have over 400 people on Slack, though. They're all on there asking questions, answering questions, sharing details about their use cases. And we have over 20 integrations with other projects in the ecosystem, Docker being one of them. Okay, so the core thing that I want you to take away from this part of the talk is that policy decision-making should be decoupled from policy enforcement. So this is the core idea behind OPA. So instead of taking policies that are specified in HIPAA or PCI or whatever, and writing them down on wikis or putting them in spreadsheets, or taking those wikis and spreadsheets and hard coding them into services next to the business logic, we think that you should decouple policy decision-making from policy enforcement by basically offloading it to a dedicated component like OPA. So for example, if we were going to build a service that exposed an API, and that API has to serve traffic requests, the way this would work is that whenever the service receives a request, it would execute a query against OPA, a policy query. It's going to ask a question like, should this request be allowed? And what's going to happen is that OPA is going to take that query, that request, or that query rather, and it's going to evaluate it against a bunch of policies and data that it has access to. And then the outcome of that evaluation process is a decision. It's an answer to the question, should this user be allowed to see this data, or perform this operation, or deploy this container, and so on. And so that decision gets sent back to the service to be enforced. So for example, if we were at Acme Corp and we had to build the accounts service, we would have to implement an API that allows users or machines or scripts or whatever to view user or account data, right? And so we might expose a REST API that allows you to call get on /accounts and then perform, and provide a username. And so in this case, Janet is accessing Alice's account via the accounts API. So the way this would work is that after the account service had authenticated Janet, right, established Janet's identity, the account service would execute a query against OPA to ask, should this request be allowed? Now, when accounts does that, it's going to supply a bunch of attributes to OPA. So it's going to supply things like the method and the path and the authenticated user that's making the request. And so then what happens is that OPA takes those attributes and it evaluates them against the policies and the data that it has access to, right? And the outcome of that is a decision, like allow or deny, which in this case is represented as true or false, which gets sent back to the service to be enforced. So if we were implementing the account service, we would interpret true or allow by just processing the request normally, and we would interpret false or deny by sending a 403 or something like that back to the client. Now, the important thing to keep in mind when you're looking at OPA, when you're trying to understand it, is that the service can be any one of these different types of components. Okay, so the service could be an internal microservice that we've built as part of a larger application, or it could be the Kubernetes API server, or it could be a gateway, or it could be a message broker or a database where you're trying to protect access to sensitive data. It doesn't really matter. And this is why we call OPA general purpose, because you can take it and you can apply it to a wide range of software. Now, in order to make that happen, in order to make that possible, we made certain design decisions when we created the project. One of the first decisions was that OPA was not going to be tied to any project or domain-specific data model. Okay, so the input, the attributes that you provide when you execute a policy query can actually be arbitrary JSON data. So you can provide things like strings and arrays and objects and so on. And similarly, the decisions, the output, the result of the query can also be an arbitrary JSON value. So like in a simple API authorization example, that output might be true or false to represent allow, deny. But in a more complicated use case, you might have some rich JSON structure that you return from the policy. Now, obviously, the policy needs to be able to make sense of the input, the attributes. It has to be able to apply meaning to them. You have to have some well-defined semantics for those attributes. And similarly, the service needs to be able to interpret the result. But on its own, OPA doesn't really have to know what the meaning of those attributes are. All OPA sees in the input is JSON, and all it cares about during evaluation is JSON. And when it's returning a decision, again, it's all just JSON or data. OK, so enough talking. What I'm going to do now is sort of walk through how you would start implementing some of these policies using OPA. So this is the policy that Justin set up, right? It says that tech support specialists who are accessing customer data must be assigned to an open ticket for the customer they're assisting. And so what I'm going to do here is switch to my VS Code editor where I've got a policy defined. So This is an example of a policy written for OPA. What the core thing that OPA provides to you is a high-level declarative language for codifying answers to questions like, can this user access this resource or perform this operation on this resource? And we call that language Rego. So in this Rego file, we have two rules, one of which grants access to the accounts API for users on their own behalf. So if you ask for your own account, then the first rule addresses that. And the second rule addresses this case of support staff accessing customer accounts. Now, the way you can understand the first rule is sort of as follows. So the way I would read this is allow is true if input method matches get, and input path matches account's username, and input subject user matches username. So we're writing constraints over the incoming attributes in the query. And what you need to just notice right now is that basically, in order for allow to be true, all of the statements in the body of the rule need to be true. So they're ANDed together. The second rule is similar. It says allow is true if input method matches get and input path matches account's username. And input subject groups contains support. And input subject user matches tickets of username of underscore of assignee. So again, the statements in the body of these rules get ANDed together. And if you want to express an OR condition, you basically define multiple rules with the same name. Now, there are a few interesting aspects in this policy. And I'm going to kind of step through them one by one. The first one is basically this last line in the second rule. Input user or input subject user must match tickets of username of underscore of assignee. This is basically looking up data that's been cached inside of OPA. So in addition to providing arbitrary attributes when you query OPA, you can also store arbitrary JSON data in the engine and use it inside of your policies. We often refer to this data as context. And so in this case, we're caching a subset of the tickets in the company inside of the OPA in order to make the policy decision. And so I can show you what that data looks like in this case. So you can see it's just yet another JSON data structure. And we've basically defined a mapping between usernames and the tickets that exist for that user. So in this case, there are two tickets open for Alice. One of them is assigned to Janet. The other is assigned to Bob. And then there's one ticket open for Karen, which is assigned to Bob. So in this case, Bob can access both Alice and Janet's accounts, while Janet can only access Alice's account. So what can we do with this? Well, one of the nice things about OPA and about Rego, the policy language, is that you can actually evaluate it just locally on your own machine to see what the values are assigned to it. So for example, if I select the allow rule here and I evaluate it, we can see that it's true right now. And so the reason why it's true is because we've given it some input data. So this is an example of a request being made by Janet to access Alice's account, right? And so since Janet's assigned to a ticket for Alice, that gets allowed. If I change this, say, to Karen, and I rerun that query, now the decision is false. Okay? Now, I'm going to change that back to Alice for the sake of the demo. Now, one of the neat things about the language is that you can actually just select arbitrary parts of the policy. So for example, if I select this reference in the import statement and I evaluate it, you can basically see that what that evaluates to is the data that we had loaded into OPA. You can do more than that, though. You can actually select arbitrary statements in the rules as well. So in this case, input method is get, and so the answer is true for that first line. Okay, so with Rego, because it's just pure logic and just pure data that we're operating on, it's very easy to just ask ad hoc questions of it, right? And this is powerful because not only can you use this in enforcement, but it's also useful for things like audit and dry run and more. Okay, now this is the black belt track. So I'm going to show something that's a little bit more interesting here. What I'm going to do is change this so that Alice is requesting her own account. Oops. And what I'm going to do here is I'm going to select all three lines in that first rule body. Now what's interesting here is that in this case, username is a variable. And when OPA evaluates this rule, what it's doing is it's going to find bindings for the variables that make the statements in the rule true. So if I evaluate this right now, it tells me that username is Alice. So by binding username to Alice, we can prove that the request should be allowed. What if I try to evaluate, wait, so hold on. What if I go and I change this back to, say, Janet, the support specialist? Well, in this case, Janet's not accessing her own account, so there are no results. There's no way that you can find a variable assignment for this body that would make the statements true, right? And that's what the second rule exists for. It exists to give Janet access to Alice's account. And so if I evaluate, if I go back and I change the input for Janet properly here, to say groups, support, right, it finds the variable binding in the second rule, and again, the answer for the policy would be true. And so, for example, if I introduce other variables here, like if I assign assignee to the result of that reference, let's type it out, username _.assignee, and I change this to assignee. Now OPA is going to find two variables. It's going to find a value for assignee and a value for username. Okay, so the statements in the bodies of these rules are ANDed together. When you want to express OR, you define the same rule multiple times. And when you use variables inside the rules, OPA will find bindings for those variables that make the statements true. And that's powerful because obviously you don't necessarily want to enumerate all the possible users in your system inside the policy, right? That's an ACL. Not very fun to deal with. Okay, so this is cool. You can do this in your editor. You can evaluate policies, but how do you actually enforce them? So what I'm going to show in addition to this is an example program. So I have a little Go program here called service.go, and if I run it without anything, it complains that it doesn't have a bundle. In OPA, we have this concept of a bundle, which is basically just a gzipped tarball that contains policy and data. And so I'm going to create a little bundle here with that policy and that data that I showed you. And I'll give it a name. And now if I run service.go on the bundle, it's just going to wait for input. And so if I type in garbage, then it just fails to decode the input as JSON and returns an error. I can give it any JSON value. If I give it the number 10, it's going to print deny. Because what happened is that it tried to basically evaluate these rules with input bound to the number 10, right? And it doesn't make sense to try to dereference the number 10 to look up the method value or something like that, right? So obviously that should be denied. But I have some other inputs here. So for example, I have an input for Alice. So this is just an example of Alice accessing her own account. And if I pipe that into the program, we see that that would be allowed. I have an example where, say, Janet is accessing Alice's account, and that should be allowed as well. And then finally, I have an example where I think Janet is accessing Karen's account, which she shouldn't be allowed to, and so that'll be denied, right? So this shows you how you can basically integrate with OPA. Now, the code for this is actually not too complicated. So this is an example of just a command line tool that's integrating with OPA, but the pattern for integrating inside of an API or inside of a service or something like that is very similar. So the first thing that you have to basically do is import this Rego package. So the Rego package in the OPA repository in the OPA project contains a high-level API that allows you to run policy evaluation. And so what we're going to do is load that tarball off of the drive. It's been provided as input here. We're going to instantiate OPA's compiler and storage. These are basically setting up data structures that are used for the evaluation process. And then we're going to decode the input that came in, right? If this was a web server, then you'd basically be reading it off the wire, and it would, represent an API request that's incoming. And then we're going to perform evaluation. And so the way you do that with OPA when you're embedding it as a Go library is you instantiate these Rego objects. And so we're providing the compiler and the store and the input to the Rego object, and we're also providing a query to run, right? So this is the same kind of query that I was evaluating a second ago in VS Code. So we're asking, what is the value of allowed here? And the result is going to be a binding for the variable allowed. And so then we go off and we run evaluation, and then we interpret the results, right? So we check if the result set is non-empty. If it's empty, that indicates that there's no variable binding for allowed. And that's, in this case, it's an error because we've supplied a default value. So the contract between the service and the policy here is effectively that it'll always return true or false. So we treat that as an error. Otherwise, we basically cast the variable binding to a Boolean, and then if it's true, then we interpret that as an allow, and if it's false, we interpret that as a deny. Okay, so this code is fairly straightforward. I think most people that have worked with Go could understand this. It's not too bad. Now, if you've worked with authorization or policy systems before, you've probably built systems like this before, but you've probably done something around access control lists or role-based access control, or maybe you've built like an IAM style authorization system. And the thing that I want to point out is that Rego is just a little bit different, but it allows you to do very similar things. So if you want, inside of your Rego policies, you can actually implement RBAC models or ACL models or even an IAM style model. Now the reason why that's nice is because with things like ACLs and RBAC and IAM, you're pretty limited in terms of what you can say, right? The types of policies that you can enforce are somewhat restricted. And so while that's useful for people that aren't necessarily experts in the policy system, the problem is that as soon as you have a use case that goes beyond RBAC or beyond ACLs or beyond IAM, you're stuck, and that's all you have. That's the only tool that you have, and you end up having to build a new system. So for example, if you need to enforce a policy based on time of day, or based on the geographic region that the client's connecting from, or based on the device they're connecting on or something like that, you can't really express those things inside of an ACL or RBAC system. And so that's what Rego addresses. It actually lets you express those kinds of policies and compose them. So if you wanted to just implement RBAC with Rego, with OPA, you could do that. But the powerful thing is that today, when your policies are simple, your admins, that's all they have to see. But tomorrow, when the policies change, when the requirements become more complicated, OPA's there. You can express these things in the language. So I have another policy here that kind of illustrates this. So this policy, this policy is slightly different. It says that tech support specialists should only be able to perform device updates during core business hours, like 10 a.m. to 3 p.m. Greenwich Mean Time, right? And so the way we're going to implement this is similar to the first one. So we're going to say allow is true. In this case, if input action matches update device, and input support groups matches support, and inside business hours is true in this case. So what this illustrates is how you can actually take logic and you can also factor it out into separate rules, and then you can refer to it. So this enables composition, it enables delegation, it enables like sharing of common logic. And so in this case, we're determining whether we're inside business hours by getting the current time of day, doing some arithmetic, and then checking whether the result is between some min and max. And so you can actually just take this right now and evaluate it. Oops, getting an error here. Oh, I need to remove the file that I created. That's why it's happening. Something's got to go wrong. Okay. Now, if I evaluate that, you can see those are the values for the variables in the rule right now. Now, it's cool because what you can also do with OPA is you can actually just ask, what are the values of all the rules in my package? And so if you do that, it'll just tell you, right? Allow is true because we're inside business hours, and here's the input that we tested with. Okay, so that's an example of a more fine-grained attribute-based access control policy for API authorization. But one of the goals of the project was to basically enable, or like I said, unify policy enforcement across a wide range of technology. And so what I want to show is an example of a policy for Kubernetes, because that's a common use case. So I don't know how many people here are super familiar with Kubernetes, but in Kubernetes there's a concept called admission control. And admission control is this kind of core mechanism for enforcing policies over resources that get created. So every time you create a pod, or you create a service or an ingress or something like that, Kubernetes executes a series of admission controllers to decide whether or not to allow or deny or mutate that request. And so this is happening before the object gets persisted into etcd and before the rest of the system is notified. And so it's this core, it's like the last place where you can enforce invariance over things like containers and services and so on that your developers and whatnot are creating in the cluster. The difference between admission control and authorization is that admission control sees the full extent of the objects that are being created. So it's not just limited to like the name of the object and the type and so on. You see all of the attributes. So you see the images that are being deployed. You see the source IP ranges in the services. You see the reclaim policy on the storage and so on. And as of recently, these admission controllers can actually be externalized. So they don't have to be built into this API server anymore. You can actually run them as webhooks. and you can just deploy your admission controller on top of Kubernetes and then configure it to call. And so there's a bunch of different reasons why you would want to use an admission controller. So for example, if you want to set up a whitelist of the image registries that can be used to deploy containers from in your cluster, this is how you do it. You use an admission controller. Or if you want to restrict the host names that a particular team is allowed to allocate with an ingress, you do it with an admission controller. Right? You don't necessarily want Bob, the new hire, to push an application into his test environment that accidentally claims payments.acmecorp.com, right? That would be really bad for business continuity. Similarly, like if you want to restrict deployments to a particular namespace based on sign-off from some group, admission controllers are the mechanism for doing that. So what I want to do now is just walk through an example scenario of how you would achieve this with OPA. So suppose that we're at Acme Corp, and we've got a whole bunch of applications that are being deployed on top of Kubernetes. And some of those applications, they have valuable data. They have data that we don't want to just have disappear suddenly. And so the applications are putting some of their data on persistent volumes. Well, it turns out that with persistent volumes, there's this thing called the reclaim policy. Okay, so the reclaim policy decides what happens when the persistent volume claim is deleted, right? And by default, the reclaim policy is set to delete. So if you undeploy the application and you delete all the resources associated with it, like the persistent volume claim, the storage associated with that application is going to get cleaned up. And so that's actually nice. As admins at Acme Corp, we like this because it means that we don't have to do a bunch of cleanup every time someone undeploys an application. At the same time, it's kind of risky, right? If the clickstream data goes away, then we can't run analytics on it, and so on, right? So we don't want to necessarily give full control over to the developers to specify this because they might not get it right or they might abuse it. So we want to be able to kind of limit who can utilize the retain policy instead. And so this is kind of like a repeating pattern that you see when you try to get to least privilege. Least privilege, it's about taking away as many permissions as possible and then only granting them selectively when they're required. And so what you really end up doing is basically setting up little exceptions here and there in the system to grant permissions as needed. So what we want to be able to do is grant the admins the ability to provide exceptions to retain some of the data in the system. And so the way we would do that is we would take OPA and we would deploy it onto Kubernetes and we'd configure it as an admission controller. And then we'd write a policy that decides whether or not to allow, in this case, persistent volume claims based on the application that they're for. So to show how this works, I've got another policy here. So this is an example of an admission control policy in OPA. And I've just assigned the input to some example data here. So you can see that that's just a persistent volume claim. This is the JSON representation of the YAML that everybody's dealing with on a daily basis at this point. And I've got two rules inside this policy. One for checking that all resources have an app label. This is a common pattern. You want to apply certain labels to all your resources, things like a contact email or a cost center and whatnot. In this case, we want all resources to have an app label. And then I have a second rule that's checking whether the PVC is allowed to use a retain reclaim policy when it's requesting one. And so what we do here is we check whether the input is a persistent volume claim. We look up the storage class associated with that persistent volume claim and check the reclaim policy on it to see if it's equal to retain. And then if the app has not been whitelisted, we're going to generate this warning or this error. And so then we check an app is whitelisted by looking up the app label on the input and then checking if it's inside of the set that we've defined below. And so in this case, only the payment application or payment and clickstream apps would be allowed to use the retain policy. And so again, as with all other policies in OPA, you can just start evaluating them. So in this case, the input that I gave is not allowed to use the retain policy or the retain policy. If I change that input slightly, we can see the effect. So for example, if I remove the app label, then we'll get 2 warnings back, basically. So you can see the set now contains 2 elements. So there's different ways of defining rules in OPA. One of them is that simple kind of allow style. Another is like this, where you define a set incrementally. It's worth pointing out that it doesn't matter what the name of the rule is here. I could call this error, and if I evaluate this, it'll be just happy. So just one thing to keep in mind when you're working with OPA policies. Okay, I think that's it for the demo. So at this point, I'm going to hand back to Justin to conclude.
So yeah, that was all really cool. I mean, I hope you understood how cool it was, because I remember when I first came across OPA, it was like, wow, this thing is amazing. This is like really what I want to use for writing policies. It's just a better way. So the first thing is you're writing rules and not writing complicated if-then-else clauses in code, which are really, really hard to read. If you've ever tried to read a complicated bit of RBAC code, you'll know what I mean. And if you haven't, you'd be thankful. But declarative rules that you can understand, you can test them in your editor and so on is really, really important. You can reuse the same policy across all applications and languages. So you can embed OPA into Golang, but you can also use it as a service, and you can call it as a service. So you can call it from any language, which is really, really useful. So you can run the same policy in lots of places. And you can see from from the demos that it'll support ways to test it and audit the code, because you can actually test the policy fragments on their own, and then you can test the overall application behavior and make sure it's actually implemented those correctly. And the integrations, there are integrations already out there for a very large number of bits of software you might want to use. So there's a bunch of demos in the repo, but there's really fun demos like an OPA controlled SSH client, where you can set the rules on whether you can SSH into a service, which is kind of totally different from Kubernetes admission controllers. And there's a lot of control. Obviously a lot of stuff around container use cases and service meshes, API authorization, and those types of things. But there's all these totally different things like SSH and PAM and all sorts of things. And if you want to integrate it into something else, it's really straightforward to do. The code's really easy to understand, and there's lots of examples to look at. And it's just building it into your own application is really, really straightforward. Especially, I mean, the Go interface is particularly simple and nice in many ways, but the API is also just a very straightforward JSON REST API. Another thing I really want to talk about really is this thing called shift left. It's a kind of horrible term in a way, but one of the things you can do with policy to make it easier to understand is that you can run these rules in lots of different places. So there's a point at which you actually enforce the rules, but you can allow people to see if how the rules are going to be enforced before that happens. So if your developer is working on some code, there's no reason why they can't have a tool that tells them whether the code they've written is going to comply with the rules. So, a kind of dry run thing that you can do on the desktop and tells you, yes, this is going to pass, this is great, this passes all the policies before deployment. And then you can test that in your CI pipeline or on like directly just by asking the question on the command line. And then rather than having to wait until you've gone to Kubernetes admission control and then it says, computer says no, and you go back. And so it really speeds up the debug cycle. And then on the other side of deployment, you can actually write rules to test that. To test the actual facts about reality. So in your Kubernetes deployment, is there anything that's running that is out of spec with this policy because it somehow got in through some other route, or maybe there's some case we didn't think of in the policy and there's a bug in the policy or something like that. So you can reuse these pieces across different parts and make a really robust system that developers can understand and the security people can go and audit in production, and there's a easy to manage and upgrade piece in the middle actually doing the admission control or whatever, actually applying the policy. There's even other things you can do around, you could use digital signatures to sign that a policy had passed already, rather than actually doing it at the point of admission control, and just check the signature later, and other things to kind of change where these things actually take place. So it's really, really flexible, and really you can use this to build really nice experience from the developer point of view, so the developers don't find policies just annoying things when you go into prod. They're actually things they can understand up front. If you want more on this, which I hope you do, there's a bunch of URLs here, the people on the Slack are very, very helpful. When I first started, I was like, I don't understand this, and they were, Torin was like, it works like this. And it's, okay. Makes sense. So do sign up for the Slack, and everything's on GitHub. It's all open source, and I think we've got a little bit of time for some questions.
Yeah, a quick question. So you mentioned to provide context outside of the request itself. In this example, it was a couple of files, but how would you do it in a real system? So the question is, how would you basically provide context in a real system to the OPA? And the answer to that is that we have APIs that allow you to both push context in. So we have a REST API. You can just call put and push in data. But we also have a suite of what we call management APIs, where you can configure OPA to periodically go out and pull down bundles from a remote HTTP endpoint, right? So then OPA is just periodically pulling them down and activating them, and that's a great way to get started. Yep. Yeah, so the question is, can you federate OPAs and have different OPAs answering different kinds of policy questions? And the answer is that yes, absolutely. So we didn't really have time to go into the architecture of OPA, but the model that it enables is like a distributed enforcement model, where we recommend that you take OPA and you run it next to your service, and then you only give it the policy that it needs to answer questions for that service. Okay.
Least privilege.
Least privilege, right? Like you don't want to have OPA running in a central place answering all policy questions for all services, for example, because that's going to impact availability. It's going to impact latency. We recommend that you take the OPA and run it next to your service and give it the policy that it needs. So when OPA makes a policy decision, it uses the policies and data that it keeps in memory. You can extend OPA to call out to an external data source, but on its own, it's not going to do that. It's sort of up to you to do that, either in the policy or by changing OPA.
Generally, for performance reasons, it's best to do everything on the set of data you've got there and not call out, because that's the way that you can scale OPA to go across everywhere in the organization, is that all the decisions are really, really fast. And there's one thing we didn't really mention, but it's very, very fast. You don't have to worry about performance of OPA. You can, because it will be handling every single query that comes for every API call, so it needs to be that fast. So bouncing out to ask questions is not a recommendation. You really should have all the data synchronized into each OPA to answer fast. Sorry. So the question is, does the OPA keep any state? No. So OPA is basically, it's an in-memory cache of policy and data. So it's not the source of truth for policy. You need to have some other source of truth somewhere. The reason why we designed it that way is because everybody's got a different place where they want to store policy, right? Some people want to put it in Git. Some people want to put it in a database. We don't want to force you to have to introduce yet another source of persistence into your system. So you typically configure OPA to pull down the policies from somewhere. And that way, like if it crashes, when it restarts, it just goes and pulls them down again. Or if you're using the in-memory one, you might just write your policies straight into the code.
Sure. Yeah.
I mean, the Go API or something like that. But if it's a service, you generally would pull them from somewhere.
Sure. So the question is, how does OPA relate to OAuth 2? How does it integrate with OAuth 2? I mean, they're complementary. Like OAuth is about it's about delegating access, right? It's about like you saying that an application has the right to do something on your behalf. OPA exists to evaluate like a decision when an API request hits a server, right? So an API request would come in and it might contain a JOT, for example, right? That's part of OAuth or built on top of OAuth. And you can just pass that JOT into OPA and evaluate it, right? Like OAuth doesn't really define the semantics of a lot of the claims. It doesn't define how they should be validated. That's sort of up to the application developer to handle. And so OPA is giving you a tool to do that kind of validation, to express that kind of logic.
So OAuth says who the person is that this should be evaluated as, but not whether they can access this resource.
Other questions?
pass to you like a list of pages, I don't know, and you something like a subset of those pages.
Yep. So the question is, can OPA, we said that OPA could return more than just like yes or no. It can return arbitrary JSON. So yes, you can define the, so the question is, how do you return multiple decisions or something like that? The answer is yes. I kind of showed it a little bit with that violation rule at the end. Like that's just generating an array of strings, right? So that's an example. You could provide a set of objects as input and then get a decision back for each one of those. Obviously that has limitations in terms of scalability, right? And so we have a whole other bunch of features that are around not returning like a definitive yes or no decision or even a set of decisions, but returning conditions that should be applied to the request. So simple Boolean expressions, which you can take and translate into like a SQL where clause or something like that, so it gets pushed down to the database for performance and scale. Yeah. I'm happy to chat afterwards about that. It's probably more interesting.
You got another question, of course.
Are there any plans for further Docker integrations with OPA? I know there's
Are there any other plans for
Justin answer
further Docker integration? Yes, it's something I'm actively looking at. There's a whole bunch of use cases in lots of places that we'd like to have it in, and I've done a bunch of prototypes that were quite informative, and yeah, so yeah, watch this space.
Other questions? We can always chat afterwards as well.
Yeah.
Okay, well, thank you very much.